In this video, I'm just simply going to introduce to you a new working definition, the working definition of the term prime number, and I'm also going to state a famous theorem for you, the so-called fundamental theorem of arithmetic. Here's the definition. A natural number p is called a prime number if the following two properties hold. One is that p is not equal to 1, and two, the only natural numbers that divide p are 1 and p itself. Of course, 1 divides every natural number by definition. Every natural number can be written as 1 times something, and every natural number divides itself because every natural number is equal to itself times 1, and so the primes are the ones for which those are the only two divisors. Here's a list of the first few primes. The smallest prime is 2, and that's the only even prime. Then the next one is 3, then 5, 7. 9 is not prime because it can be written as 3 times 3. 11, 13, 15 is not prime because it's 3 times 5. 17, 19, 21 is not prime. 23, 29, etc. So that's a list of some of the primes in order, but there are infinitely many primes, and they have very interesting behaviors, and one can devote an entire career to just talking about properties of primes. Now, the fundamental theorem of arithmetic is a theorem which expresses the fact that every natural number can be written as a product of primes, essentially in only one way. So let's look at an example of that. So here we start with the number 84. 84 can be factored as 42 times 2. 2 is prime, so that can't be factored anymore. But 42 can be written as 21 times 2, and 21 can be written as 3 times 7. So finally we get that 84 can be factored as 2 squared times 3 times 7. So all of the numbers on that list are primes, and we refer to that as the prime factorization of 84. And we say that we're counting the prime 2 twice because of the superscript of the 2. So we're saying we're counting the primes in 84 according to multiplicities. So there are actually, there are 4 primes that make up 84. 2 appears twice, 3 and 7. Okay, so the fundamental theorem of arithmetic says that one can do that for any natural number in essentially a unique way. So here's the statement of the theorem. The fundamental theorem of arithmetic says that every natural number other than 1 can be written as a product of primes. The factors in this product are unique except for the order in which they appear. Okay, so actually the proof of this is something that we'll show a little bit later. It's an example of what we call the technique of strong induction. We'll worry about that later, but for now, it's a famous theorem and you should know how to state it. Throughout the semester, we're going to be looking at well-known theorems that you should just simply be aware of, and you should know how to state them, so that when the time comes, if you're working on a problem that can make use of them, you're able to do so.